Good morning, my dear students. Last class we studied about motion, speed, types of motion and the devices used to measure time. Today we are going to discuss an important topic, that is simple pendulum. Simple pendulum. So what a simple pendulum is? It is a device used to measure time period. So a simple pendulum is a device used to measure time period. So here there are two figures of simple pendulum. The first one is the simple pendulum is at rest, which means it is in mean position. So mean position means that the simple pendulum is at its rest. Okay, then a simple pendulum consists of a rigid stand. This is the rigid stand. A simple pendulum consists of a rigid stand and next a thread and a metallic ball. So a simple pendulum consists of a rigid stand, a thread and a metallic ball. The metallic ball is known as bob of the pendulum. So the metallic ball of a simple pendulum is known as bob of the pendulum. Moving on to the next figure. In this figure, when the bob of the pendulum is released after taking it slightly from one side, then it moves to and fro motion. That is, when the bob is taken from one side and it is released, then it becomes moving from one side to another. And this motion is known as to and fro motion. The motion of a pendulum is known as to and fro motion. To and fro motion means this type of motion. The bob moves first to A, then to B and then to A and then to B. This type of motion is known as to and fro motion, and to and fro motion is an example for oscillatory motion. To and fro motion is an example for oscillatory motion. Next we move on to one complete oscillation of a simple pendulum. One complete oscillation of a simple pendulum. One complete oscillation means when the bob starts from its mean position, then moves to A, then moves to B and back to O. And this motion is known as one complete oscillation. One complete oscillation means the bob starts from its mean position, that is from O, then moves to A, then moves to B and back to O. This is one complete oscillation. Another method for finding one complete oscillation is that here A and B is known as extreme positions. A and B is known as extreme position. So the bob starts from one of its extreme position and then goes to another extreme position and then backs to the first extreme position is known as one complete oscillation, which means when the bob starts from B and goes to A, then backs to B is also known as one complete oscillation. Okay, next is time period. How can we find time period of a simple pendulum? Simple pendulum is a device used to measure the time period of a pendulum. So how can we find time period? Time period is the time taken by the pendulum to complete one oscillation. It is the time taken by the pendulum to complete one oscillation. Okay, so the equation for time period is time taken divided by number of oscillations. Time period can be calculated as time taken divided by number of oscillation. So time period is the time taken by the pendulum to complete one oscillation, and the equation for time period is the time taken divided by number of oscillations. Consider an example. If a pendulum takes 42 seconds to complete 10 oscillations, then time period is equal to, once again, if a pendulum takes 42 seconds to complete 10 oscillations, then time period is equal to, here the time period is denoted by the letter capital T. The time period is equal to time taken divided by number of oscillations. So here the time taken is 42 seconds, therefore 42 divided by number of oscillations is 10. 42 divided by 10. 42 divided by 10 is 4.2 seconds. Okay, then if a pendulum takes 42 seconds to complete 10 oscillations, then time period is equal to 42 divided by 10, that is 4.2 seconds. Units of time. We already know the basic unit of time is second. The basic unit of time is second. It is denoted by the letter S. And another units or the larger units of time are hour, HR, minute, MIN. So the basic unit of time is second, S, and the larger units of time are hour and minute. So 1 day is equal to 24 hour. 1 day is equal to 24 hour, and 1 hour is equal to how many minutes? 60 minutes. 1 hour is equal to 60 minutes, that is 60 into 60 seconds, which is equal to 3600 seconds. So 1 hour is equal to 60 minutes and 1 hour is equal to 3600 seconds, and 1 minute is equal to 60 seconds. What are the devices used to measure time? They are clocks, watches, mobile phones and pendulum clocks. And before pendulum clocks became popular, we measure time using sundials, sand clock and water clock. The devices used to measure time before pendulum clocks are sundials, sand clock and water clock. In sundials, the time can be measured by the position of shadow cast by the sun. So in sundials, time can be measured by the position of shadow, and in sand clock it uses sand to measure time, and in water clock it uses water to measure time. That is, from one vessel to another vessel water flows, and that time can be measured using water clock. So before pendulum clocks we use sundials, sand clock and water clock. Sundials use shadow, sand clock use sands to measure time, and water clock use water or any other liquid to measure time. In India, sundials are situated in Jantar Mandir in New Delhi. In New Delhi, Jantar Mandir sundial is situated. Next is units of speed. How can you define a speed? A speed can be defined as the distance traveled by an object in unit time. So the equation for speed is distance by time. From this equation we can derive the unit of speed. So what is the unit of distance? The unit of distance is meter and the unit of time is second. So the unit of speed is meter per second, or the basic unit of speed is meter per second. Then another units are meter per minute and kilometer per hour. The another units of speed are meter per minute and kilometer per hour. The symbols of all units are written in singular. That is, we can write 50 kilometer per hour, not hours, 50 kilometer per hour and 20 meter per second. So all the units should be written in singular. We have already studied the equation for speed. Speed is equal to distance by time. From this equation, we can write the equations for distance and time. Here, distance is equal to speed into time. Distance is equal to speed into time, and time is equal to distance divided by speed. So, the equations for speed is distance divided by time, and the equation for distance is speed into time, and we can calculate time as distance divided by speed. Next is speedometer and odometer. Here, speedometer is a device used to measure speed in a vehicle. Speedometer is a device used to measure speed in a vehicle and it is measured in kilometer per hour. It is measured in kilometer per hour. Then odometer is another device used to measure distance of the vehicle. It is used to measure distance and it is measured in kilometer. So, what is the difference between speedometer and odometer? Speedometer is a device used to measure speed in kilometer per hour and odometer is a device used to measure distance in kilometer. Next is an important topic, that is convert kilometer per hour to meter per second. Convert kilometer per hour to meter per second. We know that 1 kilometer is equal to 1000 meter. Okay, and 1 hour is equal to how many seconds? 60 into 60 seconds, that is 3600 seconds. So 1 kilometer per hour, which means that 1 kilometer divided by hour, that is equal to 1000 meter divided by 60 into 60 seconds, or we can write 1000 divided by 3600 seconds, that is 1000 divided by 3000 meter per second. So, we can convert kilometer per hour into meter per second by multiplying 1000 by 3600. Consider an example, that is convert 36 kilometer per hour into meter per second. Convert 36 kilometer per hour into meter per second. So, we write 36 into 1000 divided by 60 into 60, or 36 into 1000 divided by 3600 meter per second. And the final answer, the 1 0 and 1 0 can be cancelled and another 0 and another 0 can be cancelled, then 36 and 36 can be cancelled, and the final answer is 10 meter per second. So, convert 36 kilometer per hour to meter per second, that is 36 kilometer per hour is equal to 10 meter per second. Consider another two examples. The speed of cheetah is indicated as 320 kilometer per hour. It is converted into meter per second as 320 into 1000 divided by 60 into 60. The another one, blue fish, that is 40 to 46 kilometer per hour. 40 to 46 kilometer per hour can be written as 40 into 1000 divided by 60 into 60 to 46 into 1000 divided by 60 into 60. Next is distance time graph. A distance time graph shows how the distance travelled by a moving object changes with time. So, according to the time changing, how the distance of a vehicle changes. Okay, in a distance time graph, there are two axes, x and y. In x axis, time should be represented, and in y axis, distance should be represented. Okay, and there are three types of graph: bar graph, pie chart, and a line graph. In bar graph, information should be represented in the form of bars like this, and in pie chart the information should be represented in the form of slices of a circle, the form of slices of a circle, and in line graph the information should be represented through a line. So the distance time graph is a line graph. Distance time graph should be represented through a line graph. How to draw distance time graph in a graph paper? Okay, take a sheet of graph paper, draw two perpendicular lines, that is one horizontal line and one perpendicular line. The horizontal line can be indicated as x or x dash, and the perpendicular line can be indicated as y or y dash. And the meeting or the joining point of these two axes is known as origin, and it is represented by the letter O. So there should be two perpendicular lines, x or x dash and y or y dash. The meeting point of two axes is known as origin and is represented by O. Here OX should be represented by positive values and OY should be represented by positive values, but in OX dash it is represented by negative values, and also OY dash it is negative value. So OX is positive, OY is also positive, OX dash negative, OY dash negative. And in distance time graph we take only the positive values, that is we take only OX and OY. In distance time graph we take only positive values, therefore the distance time graph will be like this, that is x, O and y. Consider a table which gives the motion of a car. Here time should be represented in minute and distance in kilometer. At 0 minute the distance is in 0 kilometer, at 1 minute it is 1 kilometer, 2 minute 2 kilometer, 3 minute 3 kilometer, 4 minute 4 kilometer and 5 minute 5 kilometer. So draw two perpendicular lines and mark x, O, y and decide the quantities. That is, in the x-axis we represent time and in y-axis we represent distance. And the next step is to choose the appropriate scale. That is, for 1 minute we take 1 centimeter and in 1 kilometer we take 1 centimeter. That is, the origin should be represented by 0, then 1, 2, 3, 4, 5. And the distance 1, 2, 3, 4, 5. And mark the points according to the table. For 0 minute it is 0 kilometer. So the point should be here. And then 1 minute it is 1 kilometer. These two joints, 1 minute and 1 kilometer. And the joining lines are the point. And next is 2 minute 2 kilometer, 3 minute 3 kilometer, 4 minute 4 kilometer and 5 minute 5 kilometer. After marking the points, join these points by a line. Okay, join these points by a line. And when the line is a straight line, the motion of the car is uniform. If the graph is a straight line, the motion of the vehicle is uniform. And if the graph is not a straight line, we can conclude that it is a non-uniform motion. If it is straight line, it is uniform motion. If it is not straight line, it is non-uniform motion. Another example, a bus starts from rest at 8 a.m. A bus starts from rest at 8 a.m. At 8 a.m. the distance covered by the bus is 0 kilometer, and at 8:30 it covers 20 kilometer. At 9 a.m. it covers 40 kilometer, and 9:30 it covers 60 kilometer, and 10 it covers 80 kilometer. Okay, we draw the graph like this. First we draw two perpendicular lines, then mark x, o, y, then we represent time on the x-axis and distance on the y-axis. Then choose appropriate scale. Here I choose 30 minutes is equal to 1 centimeter, or we can take 15 minutes is equal to 1 centimeter, and 20 kilometer is equal to 1 centimeter, or 10 kilometer is equal to 1 centimeter. Then mark the points on the graph and join the points, we get a straight line, which means that the bus moves in a uniform motion. In this graph, if we take 1 kilometer is equal to 1 centimeter as the scale, we shall have to draw an axis of 80 centimeter. So this is not possible on a sheet of graph paper. So we take 20 kilometer or 10 kilometer as 1 centimeter and the time as 30 minute or 15 minute as 1 centimeter. And the next portion is that the points to remember while choosing a scale. There are 3 points. The first one is the difference between the highest and the lowest value of each quantity. The difference between highest and lowest value of each quantity. Second one, the intermediate value of each quantity. The intermediate value of each quantity. And the last one, utilize the maximum part of the paper. Utilize the maximum part of the paper. So the points to remember while choosing a scales are the difference between the highest and lowest value of each quantity, the intermediate value of each quantity, and utilize the maximum part of the paper to draw the graph. Thus we completed this chapter. In the next class we discuss the exercises and workbook of this chapter. Thank you everyone. See you in the next class.